Before we can begin discussing circles in depth, we have to talk about some basic terminology. So what is a circle exactly? A circle is the set of all points in a plane that are equidistant from a fixed point called the center. And this circle that we have on the left, and all circles, we typically call by our center point. So we would call this circle P. Now some of these terms will already be familiar to you, such as this first one, radius. And the radius of a circle, we should already know, is a line segment from the center to any point on the circle. If we extend the radius through all the way from one side of the circle through the center to the other side of the circle, this is called our diameter. So the next thing that we're going to talk about is another type of segment in a circle, of which the diameter is a special one, and this is called a chord, and not the thing that a piano plays. So what is a chord? So the definition of a chord is a segment whose endpoints are both points on the circle, unlike the radius where one endpoint is the center of the circle. A diameter is a special kind of chord. Okay, and it's the biggest chord in the circle. So it can't have a chord that is bigger than the diameter. The next two things that we have to talk about with a circle are the two lines that we see here. The first one, which you should recognize, is called the tangent line, and it only touches circle or intersects the circle once. And this one below here is called a secant line. And the secant line intersects a circle twice. But no more than twice. A central angle of a circle is an angle whose vertex is the center of the circle. Now, every central angle will intercept an arc, which is just a portion or a part of the circle. And we'll talk more about that later. And we have to talk about how we would name these arcs. So we have three types of arcs. Our first type of arc is called a minor arc. Okay, and our minor arc is going to be something like arc AB, and we have some notation. We name it with two letters. So right here, I have arc AB, and I would name it AB with this curved thing that looks like an arc over it. The next arc that we would have is a semicircle. And you've seen semicircles before. We name this one with three letters, where the third letter has to be between the two endpoints of the arc. So for example, if I said that we had a semicircle, which is formed by a diameter, from A to C, we would say that it was arc A, B, C. Our third type of arc is what's called a major arc. And this one's going to be bigger than a semicircle. We also name it with three letters. The difference this time, if we go back to our diagram, is that if I'm starting at point A, let's get a new color. If I'm starting at point A and I am ending at point B, it's going to differentiate between arc AB and the one that we want, which is kind of this Pac-Man looking thing. We call it arc ACB, where C has to be between the endpoints. So it's very similar to a semicircle, except that the arc has to be bigger than a semicircle, 180 degrees. Now, if I know that the measure of arc AB is, say, 15 degrees, and I know that the measure of arc BC is equal to, say, 50 degrees, I can determine that the measure of arc AC is equal to the measure of arc AB plus the measure of arc BC. And if you notice, our measure out in front is very similar to when we had angles, the measure of the angle. So the measure of arc AC in this instance would be 15 plus 50 degrees is equal to 65 degrees. So what if I told you you actually knew something about this topic, arc length, that you see on the screen? Well, you'd have circumference, the length around the circle, or the perimeter of a circle, and we know the formula is 2 pi times the length of the radius, is actually directly related to arc length. So we said that arc is measured in degrees. Arc length is just the fraction of the circumference of a circle. So while we have a little bit to talk about with it, you already know how to do this. So let's talk about how we would find arc length. So if we know that we had an arc measure of, say, 60 degrees. So be careful, I'm using the phrase arc measure, not arc length. There is a difference. Measure is in degrees, length is when we talk about times 2 pi r. So if our arc measure is 60 degrees, well, 60 divided by the total 360 degrees would be 1/6 of that circle. So the amount of arc that is measured, that is covered, if I was walking along this arc here, if I started at this point up here and I walked until I had 60 degrees in here, which is the same thing as 60 degrees out here, from here to here, we would be able to walk 1/6 of the circle. So let's take a moment and look at an example. If I wanted to find the length of arc AB, I would have to do a little bit of calculating. So the length of arc AB is going to be 60 over 360 times 2 pi r, the circumference. So this is the portion of the circle, the fraction of the circle, times the entire circumference. So we said a couple of seconds ago that 60 divided by 360 is going to be 1/6. So I have 1/6 of the circle times 2 times pi times 4 inches. Okay, so that's going to equal the length of arc AB. And I know that 2 times 4 is 8, so we've got 8 over 6 pi inches is the length of arc AB. And we can simplify that to 4/3 pi, or 4 pi over 3 inches. Unless you're told otherwise, do not multiply by pi. Leave everything in terms of pi. So we're already familiar with area of a circle. Area is equal to pi times the radius squared. But we have this term sectors. A sector is a region bounded by an arc of a circle and the two radii to the arc's endpoints. So I always like to think about this like a pizza slice, or a slice of pie, or a slice of cake. So if I had my center here, and I knew that this arc was cut off, this would be the sector bound by A, B. And just like we found arc length, we can find the area in a sector. So if I said that I was cutting my pizza pie into 8 slices, one slice would be 1/8 of the pie. And if we knew that the area of the entire pie was some amount, we could find out how much area would be in that slice of the pie. Well, we can do the same thing if we have just a circle and some information. First of all, where do we come up with that 1/8? Well, we cut our pizza into 8 slices. But what if I have some circle and I know that I have cut off some amount of the circle, say 72 degrees of it? I can use the same idea that I used to find the area of the arc length. It's the portion of the circle, so in this case, so I'll call this the measure of the arc, so we'll call this AB, over the total degrees times the area of the circle. So if I know that the measure of my arc, so the measure of AB over 360, and if we know our radius, say our radius was 20 centimeters, times pi, 20 centimeters squared, and let's replace our measure of arc AB with what we have, 72 degrees. And I can find that 72 over 360 can be simplified to 1/5 pi, and 20 squared is 400 centimeters squared, and 1/5 of 400 is going to be 80 pi centimeters squared. So that is the area of the sector. And we name our sector with 3 letters. So if we look at our diagram, we call this, maybe this is circle O. So this circle would be, this sector would be sector AOB. So we start with the one endpoint, we go through the center, and we go to the other endpoint, because that tells us where it's going on the circle. Now that you've finished watching the video, you should complete page 570, numbers 34 through 39, and page 578 in your textbook, numbers 13 through 16. If you have to, you can go back and rewatch things in the video, or look in the pages before the assignment.